Hello everybody, my name is Kailash Parshad from HackProKP, and in this video we are going to discuss about the transport layer protocol and its services in our cracking OSCP series. So without any further ado, let us start with the video. First of all, we are going to talk about the transport layer. Did you know that this layer is also known as the heart of the OSI model? Now you may think, what is so special about this particular layer? So let me tell you something, that this is the most important layer. Hopefully by the end of this video you will understand why is that so. Okay, to properly understand and learn about transport layer, let us imagine something. Imagine you are sending a letter to a friend who lives in another city. So you write a letter, you're going to write a letter. What are you going to do next? You're going to put that letter into an envelope. You're going to mention all the necessary details. After that, you're going to drop it off at the post office. The post office takes care of the rest. They are going to make sure that the letter is delivered safely and in order. So they're going to make sure that it is delivered by a friend. So what is important for this? The destination address, because in this way only they will know to whom we have to send this letter to. Destination address. And obviously sender address is also important, because that's the way they will know who is actually sending this particular message. Okay, to understand this in the world of networking, the transport layer acts like the post office. So this is the layer who is going to act like the post office. Let us take another example to understand the networking side of the things. Let us consider that you want to send a DM, a direct message, to your friend. So what you will need, you are going to open your computer on which multiple applications are running, because we all like to multitask, right? So let us make a computer for your friend as well. On this computer as well, multiple applications are running. Okay, so let us consider that the application we are going to use to send that message is going to be blue in color. Okay, so this is going to be the application process. Now what else we need to make sure that you are able to send the message to the receiver, to your friend? We need to make sure that you're connected to the internet. So let us do that. And let us connect the receiver as well. Okay, so now that is done. Now what is going to happen? You're going to write the message that you want to send to your friend. So let us write a small message. Let us consider that you have written the message and you're ready to send it. So you click on the send button and the message goes all the way around the internet to get received by the receiver. And the receiver finally receives the message. So this application process used the logical communication provided by the transport layer to send this message to your friend. So we used logical communication. Now you may think that what is this logical means? So here, the messages that are sent, they are sent free from the worry of the details of the physical infrastructure used to carry these messages. So we don't really care about the network that is connecting these two hosts. This host, the sender, and this host. the receiver. So we don't really care about the network that is connecting these two hosts. So there's a possibility that the hosts are directly connected. And there's also a possibility that the receiver is on the other side of the world. We don't really care about the complexity. We don't really care about that. One more thing. So according to the application's perspective, process perspective, these devices are directly connected. So there is an host to host communication that is happening. So these two hosts are communicating with each other. To understand this communication, we first need to take a look at the user data. That is the message that we have sent. So actually this message is a data stream. A stream of zeros and ones that are the bits. So a data stream may look like a random string of zeros and ones. So let us try to create a random string of this data. And this is going to go and so on. So when this user data is received by the transport layer, what happens? This data is divided into smaller chunks. This is divided into smaller segments. So let us consider segments of 4. 1, 2, and 3. And these segments are numbered. So let us consider 3 segments were created. 3 smaller chunks were created. So each segment is going to have a source port. This is the application who is sending the message. The destination port. The application process who is going to receive this message. And a sequence number. Okay, so if you are able to understand this, let us try to connect this with the example where we were writing a letter to your friend. So what we did, we were writing a letter, then we were sending that letter to the post office. But before that, we put that letter into an envelope. So these segments are encapsulated in packets. So we don't really need to understand what this packet is right now, but we need to understand that these segments are encapsulated into packets, and then these packets are sent to the post office. So let us try to connect this. So this letter is divided into smaller chunks. These are the segments. These segments are then encapsulated into a packet. This is the packet. That is the envelope. And then this data, these packets are then given to the network layer. That is going to be the post office. This post office or the network layer is going to use the IP protocol to send these messages, to send these packets to the receiver. So this means that this host-to-host communication is handled by the network layer, specifically by the IP protocol in the network layer. So this IP protocol is going to use to send the packets to the receiver. Now this IP protocol does its best effort to send the packets. So there is no guarantee if the packets are going to be delivered to the receiver. There's no orderly delivery of the packets, and there's a possibility that the integrity of the data is not maintained. So these are some of the flaws that are there in the IP protocol. Because of this is an unreliable service. So what actually happens? The transport layer extends IP's delivery service between two end systems these two hosts to the delivery service between two process running on the end systems. So these applications processes. So what is actually happening? This host to host communication that is provided by the network layer is being converted into an application process to application process communication that is happening on the end devices. So that application processes communication is handled by the transport layer and the host to host communication is handled by the network layer. So now we know that the IP protocol is unreliable. So how does the transport layer helps into this? So transport layer can improve the best effort promise of the IP protocol by using a protocol named TCP. So when we use TCP, what happens? There's an orderly delivery. There is reliable delivery. And integrity of data is there. This is when we use TCP of transport layer. So because of this, transport layer is the heart of the OSI model. Now these are some of the functionalities that are provided by the transport layer which makes it the heart of the OSI model. So now we are going to discuss about the other functionalities that actually make this layer the most important. So now let us talk about the functionalities of the transport layer. Functionalities. Okay, so starting with end-to-end delivery. This means that there is a delivery of the data from application process to application process. So end-to-end delivery. Second, we have reliability. This means that 100% of the data will be transmitted safely. Number 3 is error control. Now there is a possibility that the packets that we are transmitting get dropped or lost. So what happens in that case? Retransmission of that particular segment or packet is done. So retransmission of that packet or segment is done. Number 4, we have congestion control and flow control. So this actually deals with the flow of the data, like how much data is being transmitted at a time. So for example, let us consider there's a sender who is sending the data very fast, but the receiver is not able to receive the data in that particular speed. So what happens? The data buffers overflow. So that is a problem. So how the transport layer handles this? It handles this by using congestion control and flow control. So what actually happens? This is going to tell the sender that I can't really take this much data at this particular time. So can you send smaller data? So it is able to actually process that data from the data buffer and it is able to use that data. So that is going to be congestion control and flow control. Next we have multiplexing and demultiplexing. Okay, so what is this demultiplexing and multiplexing? So do you remember the example where we were sending a DM. So I told that there were multiple applications that were running on your computer, right? So one of the applications was the application that we use to send the messages. So there's a possibility that there are other applications as well. So let us consider that the red application is a YouTube video. So while you are trying to send a message to your friend, there's a possibility that you're watching a YouTube video as well. So how that is possible? So both of the applications, whatever data is being transmitted, it is transmitted only by one pipeline. Consider that there is only one pipeline in which all the application processes data is being flowing from. So that is going to be multiplexing. So sender side, multiplexing happens. But on the receiver side, what happens? The receiver is going to receive that data, and then it is going to give that data to the specific or the respective application that it belongs to. So this is going to be the case for the receiver. So here demultiplexing is working. Here multiplexing is working. This one and this one. Hopefully you were able to understand all the functionalities of the transport layer. Now let us talk about the services of transport layer. So there are two major protocols under transport layer. So let us talk about that. We have UDP and we have TCP. So this UDP is user datagram protocol and this TCP is transmission control protocol. So what is the actual difference? Whenever an application is using UDP, the data is actually known as a datagram. But when we are using TCP, it is known as segment. The UDP protocol is connectionless. So no connection is built before actually sending the data. Connectionless. This is unreliable. And the last and the most important functionality of this particular protocol, it is fast. Like really fast. And why is it fast? Because there is no overhead. We are going to talk about the overhead later. So this is fast, faster than TCP. So let us talk about the functionalities of TCP protocol. So this is connection oriented. So actually a connection is built before the transmission actually starts. So a data connection is going to be built, a connection between the two hosts will be made. After that only the data will be transmitted. It is reliable. And it is slow. So slower than UDP. You can say that. This is slower than UDP. Okay. So we were talking about connection oriented. So what actually happens? Consider there's a sender and the receiver. So sender says, hi, I want to connect. Receiver says, okay, let's connect. And then the sender sends again, okay, let us connect. So this is a connection that is being built before the data is sent. After that only data will be transmitted. In the case of UDP, what actually happens? Sender just blast away with the data. It says, here's the data, take it. So this is the case for UDP. So no connection is built. Second, this is unreliable. So whenever we are sending messages, there's a possibility that some of the message gets dropped. So the integrity of the data is damaged in this. But if we are using TCP, the transmission of all the data is 100%. For example, if there is an error, that particular segment in which error occurred or the packet got lost, whatever, that particular packet or segment will be retransmitted. So reliability is there. This is faster and this is slower. So what actually happens? There's a constant communication. And this constant communication is always about the window size. We are going to talk about this in detail in the TCP video. So this constant communication is the overhead that is not really there in UDP. So because of that only, this is faster. So let us talk a little bit about the window size. So actually what happens when we are sending data? So let us consider that we are sending data by using the TCP protocol. We have actually built the connection over here. Now we are sending the data. So consider this, that we are sending the data, sending the data, sending the data. So after some of the data is being sent, an acknowledgement is received, acknowledging that all the data packets that were sent have been received successfully. So that is the way the sender will know that okay, there is no loss of data. So this is the window size. After how many packets that, how many segments or how many data packets that have been sent to the receiver, after how many packets acknowledgement will be sent. So this is also known as the window size. So this is the window size. So a constant communication is done between the sender and the receiver to manage the window size, congestion control and flow control. So because of that only, this is slower. And in the case of UDP, it is faster because there is no constant overhead. They are just simply blasting away with the packets. And in this case, actually a lot of packets get lost. So an example of an application that may use UDP is a gaming application. For example, you're using Call of Duty or you're playing PUBG. So these kind of applications actually use UDP because we need to make sure that everything is happening in real time. In the case of TCP, we actually use applications that where integrity is important, where data integrity is important, and complete transmission of data is really important. For example, consider an application like a banking applications where you want to send a money order. So you need to specify all the details. So there's a possibility if you're using UDP, some of the details get lost. For example, the account number for the destination account get lost. So if that happens, then there's a problem, right? So in that cases, TCP is user. Thank you all for watching this video. Hopefully you learned something new. Have a nice day. I'm Kailash Parshad signing off.